Hello dear children, how are you all? Hope you all are fine and doing well. So dear children, in a previous video we discussed the chapter 1. So what was the chapter name? Yes, physical quantities and measurements. So in detail we discussed. I think if I am not wrong, we made a one shot video. So link is given in the description. Just go through that video to get a good command on the chapter 1. Yes children, in today's class especially we are going to discuss the concepts of chapter 2, that is a motion. Dear children, before going to start our lecture, let us see what are the important concepts which we have in this chapter. You may get one doubt, sir, why we should know that, the topics which we are going to learn. Dear children, whatever may be the subject, whatever may be the chapter, first try to know the important concepts in that so that you get a clear picture, clear idea you will get what you are going to learn. That's very important. Okay, fine children. So in this chapter mainly first we discussed about what is a rest, what is a motion. Of course there we take a few examples that we'll discuss, don't worry. Okay, so rest, motion we discuss. Then we learn about the types of motion. Especially in the types of motion we are going to cover translatory motion, okay, oscillatory motion, rotatory motion and a circular motion, of course vibratory motion also, that I missed, sorry, okay, vibratory motion. Then we discuss about the periodic motion, non-periodic motion and a mixed motion, that is a combined motion. Means some situations bodies may have more than one motion, that one we can call it the mixed motion. Okay, so once we come to the types of motion, dear children, so we will learn about speed. In that types of speed, uniform speed, non-uniform speed. So finally we are going to discuss the what is a weight, what is a mass. So you may think, sir, we are going to have a huge number of topics. Yes, but each and every topic is very important. So that's what my plan is, that dear children, in this single video I am not going to cover all the topics. See, if I want to cover means, I need to rush, or else, video will become very lengthy. I don't want that. So in today's class, what are we going to discuss? Yes, we will discuss rest, motion, types of motion. So that in a very next video, we are going to learn about the speed, types of speed, mass and weight. Hope it's very clear, children. So I repeat once again, in this single video we are not going to learn the entire chapter. Like we are going to make this single chapter as a 2 parts. In this part we will learn only till the types of motion. In the next video we will be talking about the speed, mass and weight. Okay, fine. So now without doing delay, let us try to understand the concept of rest and motion. Children, we are not going to learn separately what is rest, what is a motion. So this two together we are going to learn rest and one more is what, it's a motion. So when you can say that a body is at rest, when you can say that body in motion. Children, I have some question. Are you ready? Yes. Hey, don't forget to comment your answer. Okay. So the thing is that now, of course, as you are watching video means you are sitting somewhere else. You might be in some building. I hope you are sitting in some room or some house, some apartment. Now tell me, is your apartment at rest or in motion? Or is your house at rest or motion? Come on children, just pause the video. Think, is your building at rest or motion? Okay, got it? Hope you have mentioned your answer. I repeat once again my question. Wherever you are sitting, let us say you are sitting in a house. My question is that, is that house at rest or motion? The moment when I ask this question, so many students, they'll think that, sir, what is there to think? Of course, every day I'll go to school, back to home, it will be there only, right? It won't go anywhere. If it will in motion means, it will go somewhere else, right? That is what your, what we can say, logic and thinking. And hence, many of you think that, yes, my room or my house or my apartment is at rest only, you think. If I say that, no, your house or your apartment, it is in motion. If I say that, many of you will get surprised. Sir, what is this? How can you say like that? Being a teacher, how can you say wrong thing? Okay, let us, it's not a right or wrong. First we need to understand the concept. When you can see that body is at rest and body is in motion, then you will come to know that whether your house is at rest or in motion. So for that, we'll take a simple example. Okay, fine children. So let us say some scenery, let us try to take. Let us say here is like some tree type, let us take. Okay, it's one of the evergreen example to understand the concept of rest and motion. Okay, fine. So, okay, here is on the earth surface only, and somewhere else here, let us assume that here is one vehicle. Okay, na? So let us take a car. Hey, rich people, we are rich, right? Let us take a car only. Okay, okay, let us say car. Actually, I am not that much good at a drawing. Please excuse me for that. Okay, okay. Now, children, let us say that here one person. Okay, let us say person A. Okay, na? Here is, let us say, just person A. Ting, 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 like this. Okay. Now let us say that this car is in motion. Of course, this car is moving. This car is moving. Hey, do you think that car will go without person? No. Then we need to consider the two persons in this. Okay. Okay. Let us say that here is one person is sitting like this. Let us say person B. Actually, don't think that this person is sitting on the wheel. It's not possible. Okay, please. Okay, he is sitting inside. Okay, fine. And somewhere else, let us see the driver, and there is one more person. Let us say he is the owner. Okay, let us consider the owner. He is also sitting. Person C. So this is the situation, teacher. Are you able to see? Let me check. Yes. So here is a tree where one person is standing. Let us say person A, and two persons are there in the car, and the car is moving. Okay. Now thing is that our target is, let us talk about the person C, children. Person C. Now as long as the car is moving, as long as the both persons are sitting, okay, now what you just try to think from the point of person B. For this person B, how does this person C appears, ma? Obviously at rest only, right? Try to understand. For person B, okay, for person C appears at rest only. Okay, fine. But what about the point, or person A point of view? For a person A point of view, if you can think with respect to the person A, this person C is moving. Person C is moving, which means what? Now he may be at this position, next he may go here, here. It means he may be changing its position, right? Okay. See, same person. So person C with respect to the person B at rest, with respect to person A is in motion, which means what? Same object, same person, same particle can be at rest, can be in motion simultaneously. You may get wondered, sir, how it is possible? Either the body must be at rest or body must be in motion, right? Yes, Rachel, that's what I'm trying to tell you. With respect to what are you trying to? Means here the point of reference is very, very important. Generally, in our day-to-day life also, for a X person is there, we say that, hey, he is a very good person. But some other persons may not like, right? Same person can be loved by some person, can be hated by some other person. Why that? Let me give you some more example. Generally, I go to classes to take the subject, to teach, right? There is 30 students are there. Do you think that 30 students will like me? No, it's not possible. Some of them may like, some of them may hate. That's common. That's their point of view, right? I cannot change their way of thinking. Some people say that yes, Naresh is good. Some people say Naresh may not go to, he may not teach. Okay, that's okay. That is their wish. That is their wish. But same person is good for some people, same person bad for some people. It means what? With respect to what? It's very, very important. I make clear. Same way here also. With respect to what are you trying to observe that body? That's very, very important. Means here I can say that with respect to, let me write, with respect to person A, person C is in motion. Try to understand. Very, very, very important. Whereas with respect to person B, same person C is at rest. Try to understand. Very, 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 very important. Which means what? Same person can be in motion, can be at rest at that same time, at that moment only. So here means what? Here with what respect is very, very important. So with respect to the person A, person C is in motion. With respect to the person B, person C is at rest. Or else we can say with respect to the compartment of the car. With respect to the compartment of the car, he is sitting, is not changing its position. So now let us conclude what is a rest, what is a motion. The children, a body is said to be at rest if it is not changing its position with respect to the surroundings. Children, this is very, very important. If any object is not changing its position with respect to the surroundings, then it is said to be at rest. Then what is a motion? If any object is changing its position with respect to the surroundings, then you can say that that body is in motion. Now get back to your house or your building or your apartment. With respect to the earth surface, children, let us say that here is the earth surface. So here is your sweet house, sweet home, let us say that. Yes. With respect to the ground or with respect to the earth, yes, with respect to the earth, your house is at rest only. No doubt about it. No doubt. Then you may think, yes, sir, we are right, you are wrong. Okay. Yes, children, you are right. My students are always right. Okay, that's fine. But the thing is that, children, do you think that this earth is at rest first of all? No. Earth itself is a motion. Try to understand. With respect to the space, earth is in motion. Obviously, whatever the things are placed in the earth surface should be rotated. Yes, sir. No. Then I think you might have started thinking, yes, sir, correct only. With respect to the space, earth is rotating, means it is in motion only. As the earth is in motion, the things, whatever the things are placed on the earth surface must be in motion. But with respect to what? With respect to space. Is the point clear? Yes, that's what I'm trying to tell you, children. It's very, very important. With respect to this space, your building is in motion. Why? Because it is placed on the earth and earth itself is in motion. But whereas with respect to the earth surface, yes, your building is fixed. It is at rest only, no doubt about it. So with respect to what are you trying to think is very important. So same object can be at rest, can be in motion at the same time. Okay, fine. And one more simple example, let us take that. One more example, let us take to get more clarity. Okay, so it is one of the best and evergreen example. What is that here? Okay, so let us take that here is some railway platform is there. Okay, it is a railway platform. Okay, railway platform. Here is some chair is there. Ting, 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 ting. On this chair, one person is sitting, let us say. Ting, ting. He's reading some newspaper. Okay, reading newspaper, let us say that. Okay, and here is a train. Hey, just beside, try to understand. Not exactly. So, it's like a platform and just beside. Okay, it is a train is there. Okay, it is a train. And many passengers will be there, many seats will be there. We are considering only two. Here is one seat is there. Okay, and here is opposite seats, just we are considering. Okay, wait. Ting, 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 ting. No, let me take, yeah, that's fine now. So here is, okay, two chairs, let us say. It is X chair, Y chair, and outside chair which is on the platform is a Z. Okay, here is one person is sitting. Okay, here is one more person is sitting. Okay, that's fine. For suppose, let us say that this train, okay, now here is a train. Let me write a train, T-R-A-I-N. Now you believe. What is this, dear children? Train, you have to tell. Okay, now the train is moving. Train is moving. Train is moving. Now, as a train is moving, teacher, try to understand. Now, for this, let us say person X, sorry, not chairs. Here is a person X, person Y, person Z. For this person X, okay, now, this person Z appears as if he is moving back. Okay, now, yes or no? In fact, he is sitting there only. He is sitting there only. But for this person X, as the train is moving forward, this person X feels that this person Z is moving backward. But at the same time, see, these two persons are in train and the train is moving. Train is moving means what? Along with the compartment, they are in motion. Along with the compartment, they are in motion. But with respect to each other, these two persons are in motion. But with respect to each other, for this person X, this person Y is at rest. For this person Y, this person is at rest. X is at rest. But for these two persons, this person Z is in motion, or else for this person Z, these two appears as if they are in motion. Try to understand. This is a general example. Whenever you are doing a train journey, you can see that. Now train is what is just it's altered. Let's say it's a rest now. Now as the slowly train is moving, we feel as if this platform, the person, the trees, all we feel that as if they are going backward. It's with respect to what I'm trying to think is very important. So that's what we can say, that rest and motion both are relative terms. You cannot separate and you cannot learn. I can say that there is no body to say that perfectly 100% is at rest only, or you cannot say that 100% it is in motion only. No, any object can be at rest, can be in motion at that same moment. Hope I am clear. So this is what actually rest and motion. Children, what is the rest mode? Let us recall once again. The body is said to be at rest if it is not changing its position with respect to the surroundings. Then what can you say about the motion? If any object is changing its position with respect to the surroundings, then we can say that that body is in motion. Now let us try to get into the types of motion. In that, the best one, the first one is very, very important. I love this like anything, digital. First one is translatory motion. Translatory motion. Translatory motion. Dear children, you don't believe, same translatory motion still 11th class students also learning. If I am not wrong, many students are in a confusion. Many students, they will think that translatory motion means body is going along the straight line path. They will see I have seen many students, many people will think that translatory motion, linear motion or rectilinear motion, all are same they think. Now let us see, is translatory motion, linear motion are both same or not? So if you want to understand that, whether translatory motion means a body is going along a straight line path, can we say it just is a translatory motion? Yes or no? Yes. If you want to say it's yes or no, first we should understand what actually the translatory motion. For that, let us take a simple example, children. Let us take, here is the earth surface or some surface, some platform. We need to understand this. Okay, na? Fine. Now let us take one toy car. We take one toy car type. Okay, na? Toy car, let us say that. Okay, fine. Toy car we have taken. Let us say, children, this is wheel A, it is wheel B. Okay, na? Now let us try to give you some push. Some force is applied. So whenever you apply some force on an object, what happens? The body is moving. Slowly the body will be in motion. Yes or no? Yes. Let us say that. Let us say this is position 1. Initially this is position 1. Okay, now fine. Now let us say after some time, let us say that the body has come here. The toy car. It is a toy car. Okay, na? It has come here. Okay. Okay, na? Let us say it is A only. It reached here. Okay, na? Fine. Let us say new position B dash B dash. Let us say position 2. Position 2. Let us say that. Now, children, if you can measure the distance between these two back wheels, let us say that this wheel. Let us say that from here to here. Let us say that this wheel A covered some distance, right? Let us say it is 10 meters. 10 meters. And surprisingly, you also will notice that the distance between B wheel and B wheel, try to understand, will be to the will be second position. This also will be 10 meters only. That too in the same time. Not only these two wheels, you can take any point. For example, here is a point X. Okay, this is X point, X, let us say X dash. The distance, and let us say it's a Y. And let us say it's a Y dash. So X dash must be equal to Y dash. Means if X dash is 20 meters, Y dash also 20 meters only. So what I mean to say is that you can take, for example, we are just thinking about an object and it is in motion. For suppose, see, object means has a what is a particles, points, everything, many it will be there. Means if each and every point of the object moves through the same distance in the same time, then you can say that that body is in rectilinear motion. I repeat once. Rectilinear motion means what, children? Every point, right? Each and every point, it is covering same distance in the same time, same interval of time. For means every particle is covering, every particle. Here I have taken a tire A. Tire A is covering 10 meters. Tire B also covering 10 meters only. Means what here? These 2 points I have considered which are covering same distance in the same interval of time. Then we can say that it is in translatory motion. It is in translatory motion. Then you may get a one doubt. Sir, for suppose, then by seeing this example, you think that, sir, yes, translatory motion means what? See, sir, body is going along a straight line path. Oh, you are thinking like that. Then let me take one more example. Simple example. For suppose, here is some path like this. Some road I have taken like this. Some road I have taken. Children, do you think that always roads must be straight only? No chance. Okay. Now what I meant to say that, here, one body. Okay, here is, okay, any toy or anything, let us take more. Okay, let us take a same toy car or anything, can take one body. It is at position A. After some time, it is position B. Let us say that it is just going. Please try to understand. It is going zoom, zoom, like this is going. It's position 1. Okay, position 1. After some time, position 2. Now, what I mean to say that, let us consider here point A. Here is point B. Okay, in a new position, let us say this is the same point only, but I am naming it as just A dash, and this is just a B dash. If you can measure from position 1 to position 2, children, for suppose the distance between A to A dash is 25 meters. 25 meters. Obviously, the distance between B and B dash also, for example, here A dash is a 25 meters. Then the distance between B and B dash also, 25 meters only. 25 meters only. That's what I'm trying to tell you. If a body is in motion such that each and every particle of that body covers equal distances in equal interval of timings. In the same time, so I mean to say, in the same time, the distance covered by the each and every particle of that body is same, then you can say that it is a rectilinear motion. Now, dear children, it is in a rectilinear motion only. It is a rectilinear motion only. Then you may get one out, sir, rectilinear motion means, is it not that compulsory that body must go in a straight line path only? No, dear children, that's what I'm trying to tell you. Rectilinear motion means what? If any object is going along the line, I can say that a line might be straight line or curved line. Straight line or a curved line. Only we should see only one thing. Are the particles of that body covering the same distance in the given time? Is important. If all the particles are covering the same distance in the same time, then that body is in rectilinear motion. But dear children, rectilinear is of two types. Yes, dear children, rectilinear motion of two types. This is the first type. This one I can call it as a not rectilinear motion. Sorry, it's a translatory motion. Please excuse me. Since that I'm using rectilinear. I'm extremely sorry. Actually, this is all about the translatory motion. Translatory motion means what? If any object is in motion, so that it is going along the line, so that each and every particle of that body covers same distance in the same time, then we can say that those bodies are in translatory motion. Please excuse me if I am using since that time the rectilinear motion word. Please excuse me. Actually, it is what? Translatory motion. So, translatory motion means it is not that always body should go in a straight line path only. Translatory motion is of two types. Translatory motion of two types. So, it is the first one. This is rectilinear motion. Rectilinear motion. Linear motion. Or simply we can say linear motion. Whatever this second is the first one. Second is what actually? Curvilinear motion. Curvilinear motion. So now, dear children, rectilinear motion, what is that condition? Body must go along a straight line path. In a curvilinear motion means what? body will go along the curved path, zing, 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 like how snake will go like that. Okay, now. So rectilinear motion, the best example. Hey, look at here. If I leave this body, it's a freely falling body. If I leave this, yes, it is falling under the action of gravity, vertically downwards, means it's going along a straight line path. This you can say rectilinear motion. If any car is going in a straight road, zoom, it is coming like this. It is rectilinear motion. Same car is going zing, 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 zing like this. That is the curvilinear motion. So children, rectilinear motion, curvilinear motion, both are the part of translatory motion. So translatory motion is of two types, rectilinear motion, curvilinear motion. If someone will ask exactly what actually the rectilinear motion means, you can say that if any object is going along a straight line path, it is rectilinear motion. If any object is going along a curved path, it is a curvilinear motion. But the condition is that what? Each and every particle of the body must cover the same distance in the same time. Is that point clear? Okay, then copy this. So it's a translator motion, and the types also we discussed, that is rectilinear motion, curvilinear motion. Just copy this. Done. Circular motion. Okay, now fine children. Now just look at here. Can you see something? Okay, can you see something in my hand? What is that? Earth is moving. Okay, yes. So now look at here. What is in my hand? Hey, come on. It is in motion only. Hey, can you say this? Now, what's happening? Can you see the spinning of top? Can you feel that? Yes, yes, yes. Fine. Now try to understand. Now, what can you say about this motion, children? Here is the earth only. You can say that it is a rotating. Okay, great. It is rotating. When you can say that a body has a rotatory motion. Okay, or when you can say body has some circular motion. Children, both seems to be same, but both are not same. Okay, both are not same. A small difference will be there. Just try to understand that. So if you want to understand that, let me take a picture. So here is some object you can take. It is some object like a sphere. Children, sphere you can take. Sphere you can take. Okay, now through the sphere, let us say that we inserted one. What we can say? We inserted one spoke. We inserted some spoke. Okay, insert some spoke. So that if you just try to apply some force, this solid sphere will rotate about this axis. This spoke behaves like an axis. This only we can call it as a axis of rotation. Axis of rotation. Axis of rotation means what? This body has a motion about this axis of rotation. It's very simple. So what can you say about the rotatory motion? So if a body moves about any axis, any fixed axis, if any object is fixed axis, it is a fixed axis, it is moving about that fixed axis. Such a motion we can call it as a rotatory motion. Means in this, that axis about which it is rotating, that axis passes through the body. Passes through the body. This is very, very important. Passes through the body. Children, can you give some more examples? Can you? Yes. Ceiling fan, ceiling fan. So ceiling fan, it is in rotatory motion. Can you see that it's rotatory motion? Of course. Children, can you just give a few more examples of rotatory motion? Come on. How can you give, sir? Can you listen? But I can see. You can comment your answer. Children, come on. Give a few examples where the bodies are in rotatory motion. Okay. Got a clarity about the rotatory motion? In a rotatory motion, body has a motion about the fixed axis. Means what? That axis passes through the body. Okay, fine. Comes to the circular motion. Dear children, listen. Now look at here. So if you can see here, something I'll try to show on my screen. If you can see there. So there, the satellite is going around the earth. Can you feel that? Satellite is going around the earth. Okay, fine. And even children, let us consider the motion of earth only. Let us say it is earth. Okay, it is earth, let us say. But when you take the motion, what we can say, earth motion means, earth has two types of motion. Rotation, revolution. Rotation, revolution. Now look at, for suppose, here is the sun. Okay. We all know that, okay, we all know that earth, let us say here is earth, okay na? Yes, so let us say here is earth. This earth will be going around the sun, then you make it a wonder, sir, what makes the difference, sir? Okay, for example, let us consider here is its path along which the earth is going, and here in the place of sun you assume one axis which is passing, one axis. This axis is called axis of revolution. Here one axis, just imagine about this axis. Yes, this earth is taking some rounds, let us take that. So this axis we can call it as a axis of revolution, children, axis of revolution. So earth is going in a circular path. So first of all, what is circular motion? If a body is going, if a body has motion along the circular path, such a motion we can call it as a circular motion. But what makes the difference here? Children, here axis of rotation is passing through the body, but this axis of revolution is passing out of the body. It is, this axis is not passing through the earth, right? No. It is out of the body, try to understand. But where axis of rotation passes through the body, but here axis of revolution is not passing through the body. This axis of revolution is passing out of the body. That makes the difference. In exam they may ask you a question, how does the rotatory motion differ from a circular motion? So in a rotatory motion, the axis of rotation passes through the body, but whereas in a circular motion, the axis of revolution won't pass through the body. I can say out of the body, it passes through the, we can say it passes through the center of the circular path, not through the body. Center of the circular path, actually, like this. Okay, can you give example? Yes, hands of a clock. Yes, example for circular motion. And earth revolving around the sun, circular motion. Satellite revolving around the earth, circular motion. Hey, but here you make it one doubt. Sir, is circle also curve only, right? From here to here, if I consider, let us say from A to B I will consider. Sir, can you say this A to B is a curved path? Yes, my dear children, you are right, it's a curved path only. Then you make it a doubt. Sir, can we say it is a curvilinear motion? Oh, what a doubt, dear children. You are wonderful, really. Of course, now I need to think. Because curvilinear motion means what? If any body is going along the curved path. Yes, it is a curved path only. Circle itself is a curved, right? Curved path only. Then can we say that circular motion is a curvilinear motion? No, we can't say that. But we can say that circular motion is a special case of curvilinear motion. But when I say just it is a special case of a curvilinear motion, then you will get one doubt. Sir, आप बोलिए, what is the difference between then circular motion and a curvilinear motion? Yes, my dear, I will tell you. First, I need to tell one more point for circular motion. For example, from here to here, it's circular. If it was a purely circular path, exactly. Let's say this distance is, let us say 100 meters. Okay. Here also 100 meters. Here also 100 meters. Here also 100 meters. Means in a circular motion, if you can see the distance between the object and the center, that will be fixed. The distance will be fixed. But curvilinear motion, look at here. For suppose a body is going like this, a circular path, curved path. Here body is here first. After some time it may be here also. After some it may be here also. Part C. If for suppose it is going like this, you can imagine it as a one circle here. Okay, na? But here is there a fixed distance to the circle or something? No. So this is a small difference. In a circular motion, if you can see the distance between the body and the axis of revolution, thus distance is fixed. But it won't be in the case of curvilinear motion. So that's what we can say. Circular motion is a part of course, special case of curvilinear motion. Means all circular motions are curvilinear motions, but all curvilinear motions are not circular motions. Wow, what a point we made. Okay, so circular motion can be a curvilinear motion, but it's not compulsory curvilinear motion must be a circular motion. It is not possible. Is my point clear? Sure? Okay, yes. So this is about the rotatory motion and the circular motion. Children, now look at here. Look at here. Can you see something in this motion? Hey, is it my heart? Hey, it's not my heart. Hey, come on. Look at here. What is happening to this one? Okay, now. Okay. My heart is beating. Adola. Ta-na-na-na. Okay. So my heart is beating. Of course. Can you see my beat? Can you see my heart? It's beating. Oh, but you can see that. Yes. Yes. Can you see here? Yes. Yes. So children, just try to notice the motion of this heart. Hey, it's not like heart, it's some object. Okay, let us imagine like a pendulum. Okay, so children, find each other. So let us look at here. Here is a rigid support. Let us see, here is a pendulum, simple pendulum. Simple pendulum. OA, children, this is called mean position. This we can call it as a mean position. What is this more? Mean position. Let us slightly it is disturbed, let us say that. Then what happens? Yes, it has some motion. Let us say it will go here. Let us say its position B, again back to this position. So in between this B and C, it has a motion. Between B and C means like this, again, yes. Okay. Such kind of motion we can call it oscillatory motion. Then you may doubt, sir, without explaining, you are saying simply such kind of motion is called oscillatory motion. How to understand? Look at here. So children, if you can just notice this mean position or fixed mean position. So this body has to and fro motion. To and fro motion. This to and fro motion of the body about this mean position is called oscillatory motion. If someone will ask you, come on, show me oscillatory motion, how? You can tell. Ding, ding. This is called oscillatory motion. Okay, you can't say like that. Hey, then how can you write in exam? So in exam, you should write that. Yes, this to and fro motion of the object or a body about this mean position is called oscillatory motion. Example, yes, you might have seen some clocks, So where, the pendulum clock. The pendulum will be there. Yes, it is a oscillating, the to and fro motion. Then what makes the difference with the vibratory motion? What is the vibratory motion? Children, vibratory motion also a type of oscillatory only. A type of oscillatory only, but not oscillatory. What makes the difference? So children, let us say that for suppose let us assume like one table. Okay, na? To understand this, let us take a table. Okay, here is table. So sometimes you might have played. Generally, you just of course in your presence, your presence of what is in your parents' presence, you can do this. Take one iron scale. Okay, here let us say iron scale. Okay, now so here is some kind of iron scale. Okay, yes. Now just hold it here. Okay. Then try to just pull the scale and just leave it. Then what happens? It will have kind of motion, means it will go like this. Okay, and it will come like this also. Is the point clear? Okay, now of course this is a mean position, no doubt about it. It is a mean position. It also has a motion about the mean position. Children, first let us see what is the similarity between these two. In both the cases, body has a motion about the mean position only. But this vibratory motion, how does it differ from this oscillator motion? Because a part of its body is always fixed. A part of its body is always fixed. And if you can see, during this motion, whether the pendulum is at a point A or point C or point B, its shape is not changed. But here let us say it's a point A, is a point B, it's a point C. But at a point B, it's point C, it is a bending. Means for here, shape is changed. Shape is changed. That's it. Shape is changed. So 2 points are different from the oscillator motion. A part of its body is fixed and the shape is changed. Examples, yes, you can take a guitar or a violin. If you are playing that, the strings will be there, they will be oscillating. They will be, sorry, sir, they will be vibrating. Tuning fork, if you can hit the tuning fork, it will be vibrating. It is what? Oscillation. It is what? Oscillation. This is what? Vibration. It's what actually? It's a vibration. Okay, so this is what actually, it's a difference between the oscillatory motion and the vibratory motion. Now dear children, one of the important types of motion we are going to learn is that motion. Children, first of all, try to understand period. Try to understand, very important. Period means here which is repeated, in a regular interval of times, in a regular intervals of time. Okay, non-periodic means what? Which is not, it may be repeated but may not be in a regular interval of times. Okay, first let us try to understand about the periodic motion. For suppose the children, here you can take the case of earth. Just try to understand the earth rotation. We know that for every 24 hours, it completes one rotation. Means what? It comes back to the same point. Means it is covering its path, the same interval of time. Next, even earth revolution also. Yes, for every 365 days, let us say that. It's repeated. Even till now we discussed of the oscillatory motion. If you can see, it's going like this. So its same path is repeated in the same interval of time. Try to understand. So what is a periodic motion? Means if any object, it's any motion, for example, see, let us say some X object has some motion. Its motion is repeated in a regular interval of timings. Its motion must be repeated in a regular interval of times. Then we can say that that body has periodic motion. Children, rotatory motion comes under periodic. What we can say? Circular motion, periodic only. Oscillatory, periodic only. Vibratory, periodic only. But curvilinear? No, we are not sure. Curvilinear, the body won't come back, right? Are you sure? No sure at all. So non-periodic motion means what? If a motion is not repeated in a regular interval of timings, then we can call it non-periodic motion. Children, in our day-to-day life, mostly we will have a non-periodic motion. Mostly I can say that. Mostly, not completely we can't say that. Of course, you may get one doubt. Sir, daily I go from home to school, school to home. I am repeating, sir, same way, same. But how about the time? You need to see even time also. It's repeated. Its motion is repeated. But sometimes, depends on roads and many factors will be there. In ideal case, it is possible. But in a day-to-day life means we need to think. And a special, sometimes yes, it might be. In ideal cases, yes, you may have the periodic motion. Who knows that? You may have periodic motion. It's not a big task, it is. So try to understand. Here the motion is repeated in a regular interval of time. But here motion is not repeated in a regular interval of time. So children, this is about the motion, types of motion. Now, but you may get one doubt. Sir, is it compulsory that body should have only one motion? No, dear children. Did I say like that? No, it is not that. Look at here. Means body will have more than one motion. Such a motion we can call as a combined motion. Okay. For example, let us say that here is a ball. A ball is thrown on the road. Let us say that on the road or on the surface. So this ball is going in a straight line path, let us say that. Okay, ball is going like a straight line path. If it is going like a straight line path means it is what kind of motion? Translatory motion, strictly rectilinear motion. Okay, it has rectilinear motion. But at the same time, it will be rotating and going, right? It will be rotating and going. So this kind of motion we can call it as a rotatory motion. So now we can say that this body has rectilinear motion as a rotatory motion. Same thing you can notice if any vehicle is in motion, dear children, try to notice the wheel of that particular vehicle. if that vehicle is going in a straight line path. If it is not, it's going curvilinear. Anything is okay. Anything. That's what, instead of saying rectilinear motion, I wanted to say that what we can say, translatory motion. So translatory motion means what? It may be along the straight line path or curved path. Anything is okay. So body has more than one. Okay. So second one is drill used by carpenter. Drill used by carpenter. So to make a holes, let us this arrangement here machine. So this will be rotating. This will be rotating like this part. Okay. So it will have a motion like this. Means it is a rotating, means rotatory motion. Rotatory motion. It will be rotating at the same time. But this what we can say, this metal one, or this metal one, sharp one, it will be going inside like a straight line path. It will be going into the wood, that wood. It will be going like this. It will be going. It's like a children, look at here. Okay now. So it's like a rotating and going, rotating and going, rotating and going. Try to understand. So this is a rotating and going, rotating and so it's a rotatory motion as well as translatory motion. Strictly rectilinear motion. So this is straight line path, right? So it is a rectilinear motion or linear motion. And if you can even notice that saw used by the carpenter only, they'll be going like this, zig zing 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 zing. So this what kind of motion? Its path is a repeater. It's oscillatory motion, but it will be cutting that wood, right? So it will going downwards, like it's going like this and he is making like this, means it's a oscillatory motion, and this is what actually rectilinear motion. So this what actually combined motions. If any object has more than one motion, it is called mixed motion or a combined motion. So dear children, this is what actually today's discussion. Of course, chapter is not over yet. What are you thinking? Picture to baki hai mera dost. Okay, fine. So in the next class we will be talking about the what is the speed, uniform motion, non-uniform motion, mass and weight. Children, let us recall once again in just a quick recap. Let us say, so what is a rest, dear children? If any object is not changing its position with respect to the surroundings, then we can say that it is at rest. Whereas if any object is changing its position with respect to the surroundings, then we can say that it is in motion. Rest and motion both are related terms. Same object can be at rest, can be in motion. It depends on the observer. And next we started the types of motion. First one we discussed about the translatory motion. Translatory motion is of two types, rectilinear motion and curvilinear motion. And we have seen the difference between rectilinear motion and curvilinear motion. Rectilinear motion means what? Body must go along the straightened path. Curvilinear motion, body will go along the curved path. Next we discuss rotatory motion, circular motion. The main difference is that in a rotatory motion, axis of rotation passes through the body, but whereas in a circular motion, axis of revolution won't pass through that body. Next, oscillatory motion, vibratory motion. The main difference is that in a vibratory motion, some part of the body is fixed and their shape and size can be changed. Then we have discussed the periodic motion, non-periodic motion. Periodic motion means what, children? The motion is repeated in a regular interval of time. Non-periodic means it is not repeated in a regular interval of timings. Now finally we discuss about the mixed and combination, mixed or combined motion. If any object has more than one motion, it comes under mixed or combined motion. Okay dear children, so just keep studying, keep practicing. Okay now, keep watching our video, and of course if really you like a video, just suggest to your friends to watch our video, and ask your friends to subscribe our channel. And purely it is a free service, dear children. This is what we keep on telling you. We are not charging anyone, just we are recording the videos and just we are leaving online, so that whoever for you it's a useful, definitely they'll go through it. And you tell, so next of course we are going to discuss about the speed and types. After that, which chapter you want me to explain, just mention your comment box. And if you have any doubts also related to the subject, or if you have any other doubts also, just you can put in a message or because a comment box, so that personally I'll go through and I'll reply. If you ask any doubts, definitely I'll try to give us some answer there itself. Okay children, thank you so much, all the very best.